Good afternoon and welcome back to a Lab Insights webinar presented by Scinomix. We're happy to have you here. Today we're going to be talking about the reality of manual aliquoting. So aliquoting and pipetting in general isn't hard, but it's relentless, right? So it's going to be that repetitive strain of doing the same thing over and over, and that's kind of what we're going to be talking about today. So, as a brief introduction, I'm Lucas. I'm the Midwest account manager here at Scinomix. I've been with the company for 4 years, and previous to my 4 years here, I was studying cell and molecular biology. So, I'm pretty informed on how labs work and can be a great asset to your lab in finding and sourcing the correct automation for you. I want to turn it over to my coworker so he can introduce himself as well.
Hi, guys. I'm Mark. I've been with Scinomix for going on 9 years now. And before that, my specialty was in process automation and process development. So I'm always interested in talking about how we can make things easier on everybody in the workplace.
Yeah, absolutely. Thanks, Mark. Okay, so for a brief agenda of what we're going to go over today, first we're going to talk about the impacts of manual sample preparation and the challenges of that. Then we're going to show you some real world automation results that we got by a top tier research facility who partnered with us to collect some data over the Scinomix AQ. Then we're going to roll into a live demo, and afterwards we're going to open it up to a Q&A session for you all to ask questions. And you're welcome to ask questions throughout the webinar. Use the Q&A button in the bottom taskbar of your Zoom, and you can type those in at any point, and we'll address those at the very end of the webinar. So I want to go ahead and turn it over to my coworker, Mark, who's going to talk to you about the challenges of manual sample preparation.
Right. And I'm probably preaching to the choir here for anyone who's gone through manual sample preparation, either in the past or if they're still doing it at their labs. This is not going to sound as if it's coming out of left field. We like to talk about the first hour of when you're manually preparing your samples, and then the last hour, because it's a little bit different in terms of how you feel in terms of what's going on. The first thing I like to talk about is human error. That's what people really think of in terms of manual sample prep and the issues that come with it. So it's the variation that you see in either the fill volumes or the placement of labels or anything else. You get that variation, and you also get potential contamination that's coming from that. The first hour, you're pretty much still raring to go. Everything seems pretty much fine. It's easier to maintain, but it's that last hour with the human error that you really run those risks of the variation and that contamination. The second thing that we like to talk about is repetitive strain. I like to call that the silent enemy of manual sample prep, because it doesn't really get on the books for anyone to understand the concerns and the issues that come with that. So it's injuries, it's chronic pain, it's all the feeling for all of those who have done that before, right? Done your manual sample prep. You know that you start off in the first hour and everything seems okay, but you are oftentimes done before you are finished because of all that strain that you're feeling. You end up with mangled fingers. You can barely grip your steering wheel when you're driving home, and you dread those days when they're coming up based on that repetitive strain. The third thing we like to talk about, and that's what your bosses like to talk about, is the productivity loss that comes with manual sample prep. So you get bottlenecks in your process when everybody has to stop and manually do all these processes. So they're not free to do other people-related things, and that pushes all the timelines behind. So the first hour, you don't really feel it. Everything seems okay. You're enjoying yourself, maybe. But that last hour, you're certainly not. So any small slowdowns lead to those bottlenecks, and over time, you could be missing some timelines.
Yeah, absolutely. Thank you, Mark. And so again, we partnered with a top tier research institute to get us some data around the system. And those are the exact challenges that they were looking to address to see if this automation would in fact free them up from doing this work by hand. So their challenges of decapping, aliquoting precisely and accurately, recapping and labeling ended up being a little bit of a strain for their lab. So their goal was to automate this process so they could walk away and do some more high value discovery work that the scientists are really more suited to do, rather than, like I said, the basics that we're all used to of pipetting. So when we're talking about this research institute that partnered with us, they did a sample preparation workflow using this device. So what is that workflow is a good question. So they wanted to bulk feed in tubes. They wanted to sort the tubes that they bulk fed, decap them, precision pipette them with the same accuracy they were used to, recap the tube, and then label it. So they were able to just load in tubes into our bulk feeder that were empty tubes, load in source liquids, press go, and come back to precisely aliquoted, labeled, and recapped tubes. It was really an invaluable experience for them, to my knowledge. Okay, so what were the results that they saw? So again, we partnered with them over a 3-week period where they wanted to look at metrics such as throughput, accuracy and precision, contamination risk, carryover, as well as walkaway time in general. So they saw that their throughput was 130 tubes per hour. They saw that their accuracy was within 3.2% of their expected fill volumes. And they saw coefficient of variations beneath 2% with aqueous liquids. We're very proud of those numbers when we saw those. And then they also got that walk away time right. So with all of the throughput, they made their production needs, and with their accuracy, they had the reliability of the system, which again provided them that kind of free up their time so they go do the more high value discovery work that they wanted to do. All right, so what is the operational efficiency of all that they saw, right? So they had that sustained precision of production volumes. So the throughput was sufficient enough to where they were able to walk away and come back to an ample amount of tubes that were completed and aliquoted. They standardized repeatable sample preparation. So they had that accuracy that was going to be met through every single tube that was aliquoted without human error. They supported flexibility and scalability. The modular design of the system allowed for cross-lab usage. It allowed for multiple different tube types. And it allowed for multiple different systems to be used at once. So some labs weren't using the single channel pipette, but only want to do labeling, for example. So they were all able to benefit from this in the modularity of that system. And then the staff also gained capacity for that high value work that they were wanting to do, right? So the data analysis and all the things that really scientists are going to be proficient at. And it got out some of those more mundane processes that the automation took over, which was, again, very valuable for this lab. Okay, so at this time, we're going to turn it over for a live demonstration of our Scinomix AQ. Mark's going to go ahead and start that up. I'm going to quit sharing my screen for a moment here. And then I'm going to talk through what we're seeing in the demo. Okay, so the system is starting right now. We're going to see a tube being bulk fed in. So these are going to be those capped and empty tubes that are your destination tubes. First, our robotic gripper is going to uncap the tube. Right now, the single channel pipette is doing a liquid level detection to find the liquid surface. Once it finds a liquid surface, you'll see it aspirate. And as soon as it aspirates, it does a tip touch to maintain that accuracy and precision that you'd expect out of a hand pipette. It will dispense into your destination tube, doing another tip touch to ensure accuracy. Then it's going to recap that tube and apply a label onto it. Once the label's been applied, it will move it over into the racks. And again, this is where you're going to be left with all of those precisely aliquoted tubes that are labeled and capped. And this system really is going to be, like I said, modular. It's going to work for your needs. So if you need to add in active cooling, if your source liquids or your destination samples need to be actively cooled, this system's going to be able to do that as well. And it's just going to rinse and repeat this process of decapping, aliquoting, recapping, and labeling. Again, this is going to be great for your walkaway time. And at this point, you can go walk and have a lunch if you'd like, or go do that discovery work that scientists are best at. And you'll see here it's moving on to its final tube. We're going to do about a 3-tube run here. And if you have any questions at all over this, use that Q&A button in your taskbar. And feel free to type those in, and we're going to answer those at the very end. Once the run is done, it's going to clean itself up. It disposes of its pipette tip into the waste container so that we don't have any contamination there. And then it's going to alert the users that the run was done, and now they can interact with these tubes and send them to whatever downstream process they would like. All right, so now I'm going to turn over to Mark. He's going to talk to you guys for a little bit, and then I'll take back over with the questions at the end.
Good. So we saw the example of what our partner was doing, but I like to turn this to the audience to think, what actually are the benefits of automating your sample preparation? So we think of it in terms of generating your aliquots and labeling the samples at scale. And I like to talk about scale because most people think of scale as only as we grow business and as we need more samples to be prepared. This automation allows us to prepare for that increase in need. But scale also works in the other way. When you are preparing your samples manually, it's that necessary evil. So you want to do everything all in the same day. We're going to have one really bad day. And so you might be preparing for multiple different tests or multiple different runs within that same day. If you have automation, you can have just in time delivery of whatever those samples are. You don't have to do all 15,000 at the same time. Maybe your study is 200 samples, or maybe it's 500 samples. You can just prepare those 500 by pressing go, and it doesn't leave all of that bottleneck in that entire day. And teams, when they are automating, are looking to reduce the ergonomics trends that we talked about, those mangled fingers. We have a lot of people in the industry that are talking about how difficult it is to hire to manual processes. Once people have seen what automation can do for them, they don't want to go back. And then we have labs that like to prioritize that consistent, high quality data that comes with using automation. We have a run result that has all of the information in there. What was the fill volume? What everything is, so that you have that documentation that people are looking for. So that's sort of talking about what the benefits are. But now let's think about what challenges you're having right now within your facility. Are you experiencing that variation? Are you experiencing rework? Are you experiencing loss of product because you're performing everything manually? Do you lose that staff time because of these repetitive manual tasks? Are you having difficulty scaling up as your business grows? Or are you having issues with having to do everything in one day because everybody is disappointed in the manual process day? Are you looking in your lab for more standardized and a better compliant process within that? If these are issues that you're dealing with, if these are the concerns that you have, I strongly advise that you look into what automation can do to help you and your business.
All right, so we're going to do frequently asked questions here. Again, if you have any personalized questions, feel free to put them into the Q&A at the bottom of your taskbar. There's a button for it. And I'm going to let Mark field some questions to me, and I'll answer them. And then in the next slide, we'll do your Q&As.
Perfect. All right, Lucas. So how does automation, in your experience, impact the day-to-day workflow at individual labs and facilities?
For sure, great question. So it's going to reduce that ergonomic strain that we've been talking about, and it's primarily going to get this out of the hands of users, and it's going to allow them to do that, again, high-value discovery work, the things that are more important than hand pipetting samples, right? And it's all about that walk-away time with automation, in my experience.
Okay. So I know you showed the live demonstration, and thank you for that, but I use different labware and different stuff within there. How robust is your equipment in terms of being able to handle different labware and different limitations?
Yeah, so we can handle all sorts of different labware. You're not limited to one type of labware. We can do anything from a 1/2 mil tube all the way up to a 50 milliliter conical tube. Sometimes we can do more as well. It just kind of depends. And so that's going to allow for cross lab usage, and that's going to allow for numerous workflows. So we're never constricted to one workflow. And it's, again, going to even hold different liquid classes, and that's all going to work together to really give you that robustness from that modular design.
Okay. So is there a minimum and like a maximum dispensing amount?
Yeah, so the minimum that we recommend is about 5 microliters to stay within that range of decent accuracy and precision. And then this system can also go up to 1 milliliter fills. It is limited by the hardware to 1 milliliter without taking numerous trips. So you can go above 1 milliliter, but it's going to take 2 trips from source liquid over to the destination tube for the aspiration dispense cycle.
Okay, so what if in my process I have different dispensing volumes within the same run? Can you handle that?
Yep, absolutely. So you can control these through CSV worklist files that have unique fill volumes. This is all going to be handled by a dynamic calibration factor. So you're always going to be within the precision and accuracy benchmarks that you're used to. And you can even do higher level integrations with these systems as well. So if you want to go outside of the CSV worklist files, which would probably be the easiest way to do this, you certainly could do that as well.
Good. Okay, so when the pipetter is coming down, I saw that it like stops when it hits the liquid. How does it know where the liquid is?
Yep, so we have pressurized liquid level detection as well as capacitive liquid level detection. So if you had carbon tips, you could use capacitive, and if you don't, you could still use pressurized. Then it's going to work kind of in tandem with the tube's geometry to always ensure that the pipette's tip is in the liquid and that it's never going to be aspirating any air and reducing all of that dead volume that you'd like to omit.
Okay. How adaptable is the HU for like different types of workflows? Maybe I am not doing exactly what your research partner was doing, or can I integrate it into other systems?
Sure, yeah, you're not limited to a sample preparation workflow. You can use, like I said, many different labware, liquid classes, fill volumes, all together in different workflows. So I know some of my customers are using these for cell banking. So if you need to go outside of the realm of just a simple aliquot, you certainly could do that with this system as well.
Okay. All right. So I've used automation before, and I've run into situations with some of the equipment that I've used where I think I have like an hour-long process. So I press go and I want to go to lunch and come back and it's done. I come back for lunch and it's stuck and it's stopped on tube number 2. So what does Scinomix have in terms of error handling to prevent that?
Yeah, for sure. Great question. So this system has robust air handling that's all user selectable, whether that be discarding a tube that aired out of a drop chute in the front door and simply reprocessing with a tube that's going to be next out of the bulk feeder. It could do that. You can also do spot checks on certain errors that you're concerned about. So say you're concerned about missing a label, you can add a barcode module that's going to verify that a barcode was placed onto the tube and reprint if there wasn't one. And you can also do air handling from a fill volume perspective if you were to add our onboard analytical balance, which will confirm fill volumes based on the liquid's density. So it's always going to be within a plus or minus range of either a percentage of total fill volume or within microliters, and it's going to be spot checking all of that. So very robust air handling on this, and you should be able to walk away to lunch and come back, and the system is going to have processed all of your samples correctly.
Well, that's great to hear. Okay. But it's equipment and we know it requires maintenance. How easy is the Scinomix equipment to maintain?
Sure, yeah. So I recommend maintaining this similar that you would with any work surface in your lab. So whether that be wiping down your work decks with isopropyl alcohol or ethyl alcohol, maybe using a UV light that's in your biosafety cabinet, and or if you are changing labels, I recommend that you wipe down the print head for good print quality. Alternatively, a lot of the maintenance that's going to be done on these systems is done by a Scinomic service technician at the annual preventative maintenance. So it's really just going to be what your lab's procedure looks like, and wiping down those work surfaces would be my first recommendation.
Great.
Good questions. So now we want to turn it over. We're going to look at the questions that you've been typing in, and we're going to answer those one by one. If you do have any questions that don't get answered here, please feel free to contact us at sales@scinomix.com is the email address that will reach your sales agent, and we'll field any questions that you have there as well. You're also welcome to contact us at 314-298-9800, and we can answer those over the phone for you as well.
Perfect. All right. We have a few questions here. The first one is from Fabian or Fabian. I'm sorry if I'm butchering your name. Is this the normal speed or is it reduced speed for the demonstration?
Yeah, good question. So that's normal speed. So at the very start, it has to pick up pipette tips and has to do liquid level detection. So it starts off slower than it would actually be running throughout the duration of your process. And then again, we can kind of balance throughput and accuracy needs as needed. So if we need higher accuracy, that may be a detriment to your throughput. And if you need higher throughput and accuracy doesn't necessarily need to be within 3.2%, but within 5 or 10, we can speed up the throughput and maybe get rid of those tip touches and things like that. So that is the normal speed for what we have set up, but you can really speed up the system based on your workflow and your needs.
Good. Okay. I have a question now from Taylor, who says, how are you measuring the accuracy of the dispense operations?
Yeah, so you can add that onboard analytical balance. It'll do a density conversion using the liquid's density and then give you the actual fill volume with gravimetrics. If you'd like to add that, that is a selectable option.
Okay. So I have a question from Rui. I know I'm butchering that name. I apologize. Can this system execute serial dilution?
Yes, absolutely. Yep. So again, using that work list, you're going to be able to input the exact fill volumes that you need, and then it's going to be dispensing different liquids into each well, right?
Good. Okay. Same person. Next question. Is there any risk that the liquid can drop off from the tip?
Yeah, so we can add buffer air. You didn't see that in the demo, but we can add in a column of air beneath the liquid that's going to prevent that from dripping. So, of course, if you have more volatile liquids, you want more air, and that pipette's always going to keep the liquid in its tip. Now, it is useful to mention that our quality department sets that up for you. We take in all of your samples and your liquids to ensure that there is no droplets forming at the pipette's tip prior to dispense. We don't want those winding up anywhere other than in the destination tube itself. So yeah, absolutely doable. Great question.
Okay. This one's from Jennifer. Is this a system that would best match our business need of aliquoting one bulk into 6,000 vials? Right now, we do this by hand, and it takes 3 hours with a team of people. Um, how long would the simple process of one bulk 2 liter into 6,000 vials take?
Yeah, so it really depends. So you saw the single channel pipette working, right? So this is going to be, again, dependent on what type of liquids you're using. If you're using aqueous liquids, we're looking at somewhere in the range of 130 tubes per hour. So it's a mid throughput device that's meant to be benchtop or put into a biosafety cabinet. We also do offer different pumps, the Scinomix peristaltic pump that really is beneficial for those 2 liter bottles that won't fit on our single channel pipette's work deck. So we can really increase throughput to about 375 tubes per hour when using the peristaltic pump. The aliquotter is great for very high accuracy. The peristaltic pump's great for high throughput and good accuracy. So Jennifer, that may be something to look into is the Scinomix peristaltic pump, which is a little bit different than what you saw today in this demo.
Good. Yeah. And she said that they're about 0.25 mil in the fill. So the peristaltic pump should easily be able to handle that fill volume.
Yeah, with great accuracy marks easily for sure.
Yep. Okay. Another question. Is there any possibility for a future upgrade to add this capability to dispense 2 mil?
Yeah, great question. So we're looking for feedback from our customers to see how we can make our systems more robust all the time, right? So though it's not capable now and the conversations haven't necessarily started, if there is a use case for this across many different labs, I believe it's something that we could consider looking into. I couldn't definitively say that's something that's on the agenda right now, but hopefully. And again, a lot of the reason why that may not be on the agenda right now is because we do offer that peristaltic pump that's going to be accurately dispensing at much higher fill volumes with a higher throughput. So it may be the case that that's just the pump that would work best for you rather than a single channel pipette.
Okay. A couple more questions I have. Uh, for cell banking, is this system, will it fit into a BSC?
Yes, absolutely. So that's really its use case, right? We have one in our demo lab that's currently in a biosafety cabinet. So this being a benchtop solution, it is meant to be wherever it's convenient for your lab users to put it, right? So if that isn't a biosafety cabinet, we certainly can source one that will fit it. And most biosafety cabinets, as is, would fit the system.
Good. And this one might be about the same as the last question. Taylor's asking, how do you ensure that sterility is maintained?
Yeah, absolutely. So we have HEPA filtration if you want to do it benchtop, where we're putting positive pressure through the system and 99.9% of all air particulates are going to be filtered out. Or if you really need your lab safety procedure and sterility procedure, I should say, maybe putting it in a biosafety cabinet would be your best bet. Again, wiping it down with isopropyl where you can, or using the UV light that's in your biosafety cabinet with the lid off of the device could also work to ensure your sterility needs are met.
Good. This is a question we get all the time, Lucas. Is there an option to cool down the storage area of the already filled tubes so it's possible, like, to start the run in the evening and then leave?
Yeah, absolutely. So we do have active cooling. I believe that's what they're asking about. So we do have chill blocks that we can place on this work deck. So it's going to limit a little bit of how much usable workspace you have, but it is going to be actively cooling those samples, whether they be source liquids or going to be those destination aliquoted tubes. You can put it on either side of the device, and that's going to keep that at low temperatures while you're processing your run.
Perfect.
Great question.
Then we have a question here. Can I use the aliquoting module also as a standalone unit for filling tubes?
So yeah, great question. So the aliquotter is a standalone unit. It is a bolted-on unit to our Scinomix VXL. So if you wanted to just use the single-channel pipette side and omit labeling, you would still require the labeling module to be placed on it as they share a software. But you can certainly only use the aliquoting side of the device. And I've seen that before where some workflows are doing plate dispensing without labeling and they're dispensing into those plates. but another lab across the way is dispensing into tubes. So they're kind of mixing and matching which modules they're using, and you could absolutely do that. But do understand too, the aliquotter is going to be that single channel pipette and the labeler forming one unit.
Can you compare the throughput between pre-rack tubes versus the tube hopper system?
Yeah, very good question. So it's going to be nearly identical throughput, right? So, and the reason for that being is that we're really going to be limited by how fast the printer can print. It's going to be processing one tube at a time, as well as the fill volume itself. The gripper arm still needs to make the travel across the workdeck, even if it is using the hopper. So the throughput is going to be nearly identical for about 375 tubes if you're only labeling. And then again, if we're aliquoting, we're expecting a little bit of a decreased throughput due to the aspiration dispense cycle, somewhere in the range of about 130 tubes an hour, but certainly depends on what liquids you're aliquoting, as well as depending on kind of the balancing act between throughput and accuracy. Higher the accuracy, typically lower the throughput. Higher the throughput, typically lower the accuracy. So we kind of want to balance that. That's best for your lab's use, right?
Okay.
Yeah, great question though.
So what I've experienced too, the value you're getting with the tube hopper, which we call our bulk feeder, the VXI, is really in preparing for the run beforehand. So rather than having to individually place tubes into a rack, each individual tube, before you start the run, you're just dumping tubes into a hopper.
Yep, absolutely. And again, if you have questions, sales@Scinomix.com, or come see us at LRIG in Philadelphia. That's the Laboratory Robotics Interest Group if you're in the area. And or if you're out here in the Midwest, in Chesterfield, St. Louis is going to be the LRIG Midwest. We're going to be showing off our Scinomix Smart Scribe there, and we'd love to see you if you are in the area. Thank you so much for your time. It's a pleasure.
Thank you guys.